that the ocean which is there, so that ocean is supposed to be a static, but it is dynamic. It is a home of so many phenomena which are taking place on our earth surface, specifically climate, ocean or water, ocean water which is there. So that ocean water is not affecting the ocean only, that ocean is also affecting the coastline or the land areas as well. All right, so that's all about the AMOC. Now we are moving ahead towards the ocean water movement. Previously we discussed about the ocean currents. Ocean current is also one of the way in which the ocean water is moving. So whenever I use this word movement, so this word movement means something is moving. Something will move whenever we have a gradient. So in geography, whenever we have a gradient, as a result of gradient, there will be some sort of movement. Okay. Now, if we talk about this ocean water movement, so there are two ways in which the ocean water could move. Okay. So first we can have a horizontal movement. Okay. Horizontal movement means like we have a movement throughout the surface area. So whenever we have a movement throughout the surface area, so that movement is being referred with respect to the currents. Okay. And with respect to waves, we have to cover waves. We'll see in a while. So currents are there. Then you have a vertical movement, means water will have this kind of movement, vertical movement. So with respect to the vertical movement, we have a upwelling and downwelling. I hope there is a clarity with respect to the upwelling and downwelling. So now we have to cover two small topics which are very much important, specifically for geography. So we have to cover waves and we have to cover tides. Okay, and both are different when it comes to their origin, their genesis, etc. All right, so this ocean water is highly dynamic, I told you. And when it comes to the dynamism of ocean water or oceanic water, so here ocean water have some sort of, you can say, like a variation with respect to temperature, salinity, density influences is there, density difference is there. So all of these features are there with the ocean water. Now when it comes to ocean water, I told you with respect to the heat redistribution, and that heat redistribution is because of the atmospheric scenarios or atmospheric conditions. But we do have some other factors, and these factors would lead to the origin or genesis of some horizontal as well as vertical movement of ocean water, I would say. So like when we have a wave, so these waves are actually the result of winds, those who used to be there on the earth's surface. Okay, so when these winds are there on the ocean surface, so those winds would lead to some sort of, you can say, upsurge and downsurge. Then we have a tides. So these tides are actually the result of gravitational pull of celestial bodies. It is basically the result of gravitational pull of sun, moon, and yes, as a result of earth rotation. So we have a different factors here. Okay, unlike currents, we have a pure climatological, pure geographical concepts. Okay, whatever we have learned as of now, so based on that pattern, we have a particular, like a predictable pattern in which the ocean currents used to appear. But we do have a same thing, but like when it comes to the genesis, origin, these are different. Let's see how and in what way they are different. So sun and moon they affect tides and all. Okay, so when it comes to horizontal as well as the vertical movement of ocean water, so we have a both horizontal as well as the vertical motion in ocean water bodies. Okay, and when it comes to the horizontal, so we have a like these currents and waves. When it comes to vertical, so we have a tides and upwelling and downwelling. Let's have a deep dive on waves as well as current. So here on your screen you can see, guys, we have a waves. Okay, that has stopped now. Okay, all right, so first you have to see this animation, guys, and see this as well. Okay, see this and see this. Now if you see this diagram, so you might have observed that the kind of waves which are there on the water, you might have observed these waves in water bodies, in ponds you might have observed, in lakes you might have observed. I mean, in almost every water body you might have observed. So here if you see, like there is a some sort of I would say upsurge and downsurge. Okay, however, upsurge and downsurge is itself a technical term. So whenever we have a upsurge, so here you can see like we have a upsurge of water, then that same water is actually moving. So this is the movement of water here, but this is the energy which is moving. Okay, it is the energy which is moving. It is not the water which is moving. Here if you see, the water will have a like just up and down kind of oscillation here in this circular motion. So this up and down motion is there. If there is a particular proper horizontal movement, so there must be some sort of movement of this water mass. Okay, complete column supposed to be moved, but here the complete column is not moving, guys. Okay, here we have a surface, and here on the surface itself we have some sort of up and down set of oscillation, and these oscillations on the ocean surface are being called as waves. Here you can see you have a duck here. Okay, so this duck is subjected to some sort of upsurge as well as the downsurge of water, and it appears that the position of duck is changing, but the position of duck is not changing, guys. Here it's just an energy in form of wave is moving here. Okay, it's not a water which is moving. Here the energy is moving. When it comes to the water movement, so water is having a up and down movement, that's it. Okay, so this is how we have a ocean waves. Now I'm stopping the animation, guys. So we have what the surface oscillation of seawater, and this surface oscillation of seawater is basically because of wind. See guys, what happened that whenever we have a ocean water, okay, so here we have a ocean water. Okay, let me draw somewhere else. Okay, here I'm drawing, guys. So I'm just a bit out of the frame, but I hope you will adjust. So suppose you have some sort of let's say the ocean surface. So here we have a ocean surface. Okay, no, like we have a water. We could have a some sort of horizontal movement. So technically it is very much difficult to distinguish between the waves and currents and tides or upwelling and downwelling itself, because all of these processes look like same. There is some sort of displacement of water, but intrinsically all of these phenomena are comparatively different with respect to their origin, genesis, impact, everything. So suppose you have a ocean water, and I'm just considering that now water is idle. Now you might have observed why we have some sort of ripples on the water surface. Ripples are because of the wind. So whenever we have a wind here, now what this wind will do, now wind is moving because of the gradient, okay, because of the pressure difference. So here we have an energy in this wind. So what would happen, guys, that when this wind is there, now what this wind will do, wind will going to interact with the water. If we have a more area, means if we have a more fetch, technically that will be termed as fetch. If we have a more area, it means if we have a more open ocean, so over the open ocean, what would happen, the more wind, I mean the wind gradient would be accordingly, means more energy would be there in winds. As a result of this, what would happen, guys, that when the wind is there, so this wind would lead to the upliftment of water. So here, because of the wind, this water would going to uplift. Okay, this water would going to uplift. In other words, I would say that the energy of wind is translated in terms of water. Okay, so energy of wind is translated in terms of water. So here we have a piling up. Okay, then we have a continuous stream of wind. Okay, so as a result of that, there will be a continuous uprising of this water. Okay, continuous uprising of this water, which is supposed to be in this way, but as a result of like a straight in this way, the water supposed to be, but because of the wind action, we will have a piling up, and this water which is here, A and B. So here in the A portion, we have an upsurge. So here at the B portion, we will have a downsurge. Okay, so that's how this water will going to appear in this way, guys. Okay, here we have an upsurge because of the wind, and as it is like this water which was here, now that water is receding and contributing towards the formation of this height, guys. Okay, so here what is happening, that the water which is above or which is hereafter, so that water is receding, and as a result of that, you will see drop. Okay, you will see downsurge. Continuous winds are there. Okay, continuous winds are there. As a result of continuous wind, further there will be some sort of you can say accumulation of energy. As a result of that, this water, or let's say this wave would be formed in this way, guys. Okay, here you might amaze that we also have a impacts. Okay, okay, I just lose that. Anyone, anyways, I will redraw it again. So here we have a wind. Okay, we have a wind. As a result of that, we have a what, upsurge. Okay, we have a upsurge here. Upsurge of water is here. Okay, and the water hereafter, I mean, like the water which is supposed to be like this, now this water is receding, and that's how there is a some sort of, you can say, downsurge, because the same water is shifted here. Okay, and the shifting of this water, like the energy is providing by these winds or the action of wind. So here what is happening, the energy which is here in this wind, now this energy is there with the water. Okay, and because of this, when we have a upsurge in this way, so suppose we have a upsurge in this way, and whenever we have a water, so water will also have a some sort of mass. Okay, and on earth we have a gravity. So as a result of gravity, what would happen, like this water which has uprise means have attained some sort of mass, and if that mass is greater with respect to the energy of wind, so under the influence of gravity, guys, what would happen, that this water which has uplifted, now that same water would going to downsurge. Okay, that same water would have a some sort of downsurge in this way. Then again the wind action will be there, wind will have a upsurge, then gravity would have a some sort of downsurge. So this up and down, this up and down kind of motion is there, and when we have this kind of motion, that is being known as ocean waves. So first part is playing by winds, second part is playing by gravity, and as a result of this combined action of wind and gravity, you will see that we have an up and down kind of motion, rhythmic oscillations are there, and because of these rhythmic oscillation, you will see that waves will have a some sort of pattern in which it appears that the ocean surface is moving, but ocean surface is just propagating the energy. Water particles are moving like up and down in this animation, and in this animation I hope you have a clarity. All right, I hope this is supposed to be start now. Okay, okay, hold on. See, so this very first part, I mean, this is what uplifted by the action of wind, then with the aspect of gravity, it is actually falling. So here there is a propagation of energy. There is no shifting of water mass here, guys. Okay. All right. So whenever you have a surface oscillation of seawater, mainly by wind carrying energy across the ocean without transporting water itself, that is what the waves. And yes, here you have a horizontal movement, and I told you you have a rhythmic oscillation as well. And as this energy will going to propagate, in other words, as this wave would going to propagate, as a result of this, water particles will have a some sort of oscillation rather than the permanent displacement. So permanent displacement is not there. There is just, we can say, shifting of water mass, guys. Now here, like a basic, if we see, for example, so here if we take a reference of this particular, let's say, sea level. So here this is what the sea level is supposed to be, and because of the energy which has been there because of the wind, so it will going to rise, and ultimately because of the gravity it will going to sink. Then again it will going to rise, it will going to have some sort of, let's say, let me make it properly. So here there is a rise, here you have a drop, here you have a rise, here you have a drop, here you have a rise again, here you have a drop. Okay, so this is what the action of wind. So it is basically the propagation of energy which was there with the wind, now that has been moving on the ocean surface, guys. So if you take a reference of this, so when you have a two same interval, so that is being known as wavelength, the highest point to which water would going to upsurge, so that would be known as crest, and the downmost point to which water will drop as a result of gravity, that would be called as trough, or trough, you can say. Okay, and here you will have a some sort of, you can say, circulation of these molecules, water molecules, in this way. Now there is a amazing catch. Now amazing catch is what? That there is a negligible water movement below the half of the wavelength. Suppose this is a wavelength, and when we talk about the movement, that to what extent it would going to shift the vertical water or the vertical slab of water. So half of the wavelength. Suppose we have a wavelength like this, so half of the wavelength. If we have this much depth of water, here there will be a driving of circulation. Below this there will be a no circulation. Okay, means this up and down oscillation would not be there. Clear? Rhythmic oscillation would not be there after half water of the wavelength. Moving ahead. So these wind blows across the ocean surface, and this air moving faster than the water, and as a result of this there will be a friction, and this friction is like a transfer the energy from wind to water, and small ripples are there. Ripples increase the surface roughness. Ultimately wind energy is transferred over the ocean surface. Sustained wind action is there, continuous wind action is there, and as a result of that there will be a formation of crest. Okay, so sustained wind energy is there. As a result of that there will be a formation of crest. And yes, the second part means gravity would going to pull, and as a result of that this raised water would be down back. Okay, so here the raised water would be down back, and as a result of this down back, what we can say that there is some sort of wave formation in this way. So it is a propagation of energy rather than the movement of water. So here in this waves, water movement is not there, guys. Okay, water movement means, I would say, water transfer with respect to the currents, it is not there, though we have some sort of movement in water, that's there, but I'm just taking a reference from ocean currents, that the ocean currents kind of movements are not there. In ocean currents we have a permanent water displacement from the equatorial region towards the polar latitudes, but here we don't have these kind of things, that we have some sort of displacement. It appears to us that water is displacing, but here water is having a just up and down kind of oscillation. So if we have an oscillation, that means water is not shifting. Technically that would be correct. Okay, perhaps there is a like a propagation of energy over the different latitudes in ocean surface. So gravity is, here you can say, the restoring force, which is actually responsible for the downsurge or backward portion of this wind. Now when wind will push, gravity will have a wind push, and gravity pull create the oscillation. So up and down kind of movement is there. We have already explained this thing. Okay, and that's how the energy will going to move as a wave, like with respect to the forward water which is supposed to be there. And whenever we have a wave growth, so this wave growth will depend that how much you can say height would be there, how much wavelength would be there. So this wavelength or this height kind of significance would be derived from wind speed, duration, and yes, fetch. Fetch means the distance which is there, the distance of wind travel, you can say, or you can say the open sea if it is there. So the fetch would be more the fetch, more the wind speed would be, more the wind speed, upsurge or the raised water would be. And ultimately you will see that these ocean waves could be larger or could be small, could be you can say ocean waves could be larger, or ocean waves could be, you can say, lower in specific regions. So throughout the earth, if you see, so this distribution is based on the pattern of winds, guys. Okay, and I hope we have already covered this wind part. I hope now you are able to recall that in what areas or in which areas these winds would be faster. If these winds are faster, specifically on the sea surface, you can expect that waves would be accordingly, height would be accordingly, every other aspect would be accordingly. So here if you see Southern Ocean, which is ranging from 40 to 60 degrees south specifically, it's because here you have a more fetch. Here you have what? More fetch, because landmass is less. We have an open ocean, so wind will have a more uniform surface to travel over the ocean for a greater period of time. So here we have a strong persistent westerlies, and they are known by this name: roaring 40s, furious 50s. Roaring 40s means over the 40 degrees south latitude. Furious 50 means over the 50 degree south latitude. The winds are there, and these winds, they are producing noise. while traveling. It's because of the friction difference. It's because of the friction which is causing on the sea surface. It's because of the uniform surface of water which is there in the southern hemisphere. So these winds literally produce sounds. Yes, you'll see, I mean, you'll hear that particular sound if you hear on this particular latitude. I never been there. Okay, I never been there. I've just heard it is there in the books, so that's why I'm telling you. So like it is highest and the most powerful waves on the earth would be in this particular region, North Atlantic and North Pacific. If you see, specifically in the mid latitude region, so here you have a regular temperate cyclones, and these regular temperate cyclone and winter storms will result into some sort of height or some sort of raised water that would result into some sort of mid-level ocean waves. Large ocean basins are there, and they provide some sort of high energetic storm, specifically in Atlantic water. Cyclone prone tropical oceans, when they are there, so there is a extremely strong winds because of the extreme pressure gradient which is formed, the close isobars in cyclone. So these close isobar will result into speeder winds, and as a result of speeder winds, you will see that the more height in waves would be there accordingly. All right, so very high and short-lived because cyclone itself is a short-lived phenomena. Equatorial region, doldrum, if you see, so doldrum is a calm region, and here the wind deflection is not there. Wind deflection is not there because of the less Coriolis force. As a result of less Coriolis force, weak, or let's say this doldrum would have some sort of calm condition, and weak and variable winds are there, resulted into frequent calm condition. If there is a no active movement in wind, so as the ocean waves or movement in the ocean waves would be very much less. So here you will see, contrastingly with respect to this latitudes or this area, you will have a less, I would say, some sort of aspect when it comes to the ocean waves. Then if you see enclosed and semi-enclosed sea, like Mediterranean Sea, like Baltic Sea, like Red Sea, so because of the limited fat, because of the less area as compared to the southern hemisphere, so there you will see that you have some sort of weaker wind system, and as a result of that, you will see that we have some sort of less wave height, specifically in these enclosed or semi-enclosed sea. Tsunami is a kind of wave, guys. Okay, tsunami is a kind of wave. About tsunami, we will have a more deep dive in next upcoming session. Till then, study hard, take care, bye.